everyone, this is lesson 3, day 2 homework. I'm going to do a video key for this one. I had a lot of people not turn it in at all. So you can't get those points back, but you can get points for going ahead and making the correction. So essentially just copying this down. But with word problems, you need to at least attempt them. Write down what you know. This problem deals with area and perimeter of a rectangle. So perimeter of a rectangle is 2 length plus 2 width. Area of a rectangle is length times width. We know the perimeter is 54, so 54 is equal to 2L plus 2W. And area is 180, so 180 is L times W. For this one, I would go ahead and reduce that top equation by 2. So 54 divided by 2 is 27, is L plus W. And 180 is still L times W. So I would use substitution with this one. You can either divide this by L or W and then plug it in up here, or you can subtract L or W up here, so like minus W from both sides. Means that L is, I'm going up here, L is equal to 27 minus W. So we can take this value and replace the L in the other equation. So 180 is equal to 27 minus W times W. Go ahead and distribute that through, and this is kind of all over the place, but I'm going to come over here. So 180 is equal to 27W minus W squared. Get this set to 0. Actually, I'm going to do this the other way. W squared minus 27W plus 180 equals 0. So I just moved everything to the left. And then factor and solve. The reason we get 2 answers with this is because typically it will give you both dimensions. And so W, what multiplies to 180 and adds to 27. I'm going to pause and figure that out myself. Okay, so 12 and 15 adds to 27 and multiplies to 180. So W minus 12, W minus 15. So W equals 12. And then the other dimension, length, is 15, or vice versa. It really doesn't matter which one you put. But it is 15 centimeters by 12 centimeters for our dimensions. Okay. The next one is talking about a triangle. An area of a triangle is 1/2 base times height, or base times height divided by 2, same thing. And it's talking about the hypotenuse. And when we're dealing with the hypotenuse, we're usually dealing in a squared plus b squared equals c squared. It's a right triangle. And so the legs are the ones that form that right angle, which are your base and your height. So base and height. So we can replace in Pythagorean theorem saying the base squared plus the height squared is equal to our hypotenuse. I'm going to keep that as c squared. All right, so now now that we have similar variables, we can plug in what we know. We know that the area is 84 feet squared. So 84 is equal to 1/2 base times height. Go ahead and simplify that. Get those variables by themselves. So 168 is equal to the base times the height. Right? We also know that the base squared plus the height squared is equal to the hypotenuse, which is 25 squared. Again, go ahead and simplify that. So base squared plus height squared is equal to 625. All right, and then so now we have our system. So we have this and we have this. I, again, tend to use substitution on these. It's not really conducive to elimination. We don't have anything that's easily made to where they're opposites. So for this one, I would solve this top equation here. And so say like base is equal to 168 divided by h. And we're going to plug that in here for base. Okay. So 168 over h squared plus h squared is equal to 625. We're going to square everything in here. Okay, so squared everything there. Then I'm going to clear my fraction out. So I'm going to multiply everything by h squared. So then we end up with 28224 plus h to the fourth is equal to 625h squared. This is a quadratic-like equation, and we did this in Unit 1 as kind of a review. And then when we factored polynomials, we did similar problems too. Get this set to 0. And we're going to factor this out just like we would a quadratic. So this will be h squared and h squared. We will get two answers. But because we're dealing with squares, we're not going to take the negative because we're dealing with dimensions. And so don't worry so much about that. Your answers will represent your height and your base equals 0. So this is going to take, big numbers take some work to factor out. So I'm going to show you kind of a cheat to this system. I'm going to take this equation and type it into my graphing calculator. And so we have x to the fourth. I am switching my letters here because Desmos does better with those. Now I don't remember. Minus 625 and plus 2824. So minus 625x squared plus 2824. Okay, so I'm going to zoom way out here. And so you can see it crosses this x-axis 4 times. We're not concerned about the negative answers, but either way, this will give us the numbers. And it actually gives us the square root of the numbers. So one of the roots is 7, which means that in one of my parentheses, hopefully you can kind of understand this, is going to be minus 49. Because when I solve this, I'm going to get 7. Minus one of the other roots was 24. So in my parentheses is 24 squared, which is 576. I don't know why I used a calculator for that. Minus 576. So you'll see if you take 49 times 576, you get that 28224. If you take 49 plus 576, we get the 625. Okay, so we have our answers there. We know that when we take h squared equals 49, so h equals 7, and h squared equals 576, so h equals 24. Again, not worrying about the negative aspect because we're talking about dimensions. And so the other two sides are 7 and 24 in no specific order. Those are feet. Okay, but I saw when I was grading someone, they said, why do we have two answers? Because the negatives are still there in terms of the polynomial, but because we're talking about an application, we're going to ignore that. Okay. All right, making a stovepipe. My Dad has actually done this, so this is practical application here. The rectangular piece of sheet metal has an area of 1,200 inches squared. We're going to fold that into a cylinder. If you've ever taken the label off of a can, you know that it is just a rectangle wrapped around of a stovepipe with a volume of 600 inches cubed. Well, area of a rectangle in this case is x times y. Volume of a cylinder is pi r squared, which is the area of the base, times the height of the cylinder. Okay. So yeah, in terms of x and y, the circumference of this is x, and the height of this is y. Well, circumference, this one I know is a little bit tricky because you have to reach back into your geometry. Circumference is pi times diameter. And so x is equal to pi times b. Area is pi r squared. Let's change our d to 2r. And so in terms of r is x divided by 2 pi. Okay, and h is y. So now we can write volume is pi times x over 2 pi squared times h, which is y. That is probably the trickiest part to this whole problem, is getting your volume in terms of x and y. Okay, so hopefully that made some sense. All right, so now we can substitute in our values. So we know that 1,200 is equal to x times y, and 600 is equal to x squared y over 4 pi. Here's how I got that. I did x squared over 4 pi squared times pi times y. This cancels one of them, and then I just put that over the top. Okay, so that's where that came from. Well, x squared y is the same as x times y. So right here, we have our xy. So we can substitute, oh my goodness. We can substitute in this with what it's equal to. So we get 600 is equal to 1,200 x divided by 4 pi. That divides evenly, so 600 is equal to 300 x over pi. I'm going to multiply by pi over 300. Those will cancel, so x is equal to 2 pi. So y is equal to let's do it would be 600 over pi, because it will be 1200 divided by 2 pi. Okay, so in terms of pi, these are your dimensions. You could plug in 3.14 for pi and get an approximation, but I'm totally fine with these answers as they are. Okay. All right, intersection of a parabola and a line. On a sheet of graph paper or using your graphing calculator, draw the parabola y equals x squared. So that's just your parent function. Then draw the graphs of the linear equation y equals x plus k for various values of k. Try to use values of k so the line of the parabola intersect at 2 points for this, for some of your k's and not for others. For what value of k is there exactly 1 point of intersection? Use the results of your experiment to make a conjecture of k. And the following system has 2 solutions, 1 solution, or no solution. Prove your conjecture. So what this is asking, and if I go to Desmos, I would use Desmos for this one instead of your graphing calculator, and here's why. If I graph y equals x squared, I can also graph y equals x plus k in Desmos and add a slider. And what that means is I can sit here and change the value of k to be anything I want. You can extend your slider bigger or smaller. All right. Well, you can see the bigger k gets, all right, then I have those 2 points of intersection. All right. As k gets smaller and smaller and smaller, eventually well, even right there, I have 2. So if I can get it to just touch in one spot, then that would be just a single solution. Anything below that single solution is no solutions at all. I still think that's touching in more than one spot, but I could be wrong. Might just be there. Okay. So it looks like anything below 1/4. So we can solve that algebraically as well. But we don't really need to because we've got our point of intersection here. I can't draw a straight line. Okay, so we can see on our graphing calculator, I still didn't do it. This point here is 0.5 and 0.25. But our k value, which is the y-intercept in this case, was negative. Okay, sorry about that. So we know that we have 2 solutions when k is greater than negative 0.25, goodness, or negative 1/4. We have 1 solution when k equals negative 0.25. And we have 0 solutions when k is less than negative 0.25. Okay, we can prove this by plugging in this value for k and solving if we need to prove our conjecture. So we have y equals x squared and y equals x minus 0.25. So let's set these equal to each other. So y equals, excuse me, x squared equals x minus 0.25. I'm going to write this as a fraction because it's easier to factor and stuff. So x squared minus x plus 1/4. Actually, I'm going to complete the square here. And plus 1/4 equals 0. So what multiplies to 1/4 and adds to 1, both negative. I'm going to go back and complete the square here. So sorry, then I factored it. So this is why we only have one solution, because it's the same both times. And so x equals 1/2, which we saw here at this point of intersection, right? If we change that value at all, we're either going to end up with two solutions or something that won't factor or intersect at all, something that won't work or solve. Okay, so this proves your conjecture. Sorry, I keep getting interrupted, so lots of distractions on this one. 5 is a challenge question, so I haven't been marking you guys off if you don't do them, but I would like for you to try this one. I think I'm still recording. But just follow the hint and do what it says. So we're solving these systems. I know we haven't worked with logs yet, but you can see these are the same, so they'll cancel out. So 3 log x is equal to 3/2. Divide both sides by 3, so log of x is equal to 1/2. I don't know how much you guys remember about logs. We're going to do logs and exponentials soon. But 10 to the 1/2 power is equal to x, so x is equal to the square root of 10. You could plug that in and then solve for y. This one, same thing. We just need to convert. So we note that this can be rewritten as 2 to the x plus 2 to the y equals 10. And then we have 2 to the x squared plus 2 to the y squared is equal to 68. And as I'm working this out, I'm noticing the level of difficulty is a little above what I want to spend the time to go through on this video, but I will post the full solutions to these as well. And so I'm just going to end there since that's the end of the required problems. Hopefully some of you guys pushed yourselves a little bit to try a few of these. Okay, so if there's still questions after all that, please let me know. Word problems on a test won't be probably as complex as the last two, but certainly the first two types like that will be on there. So let me know if you have questions. Have a good rest of your day.